Yeah, very good morning to all of you. My voice is audible. पता ही नहीं चलता है ना. Hello.
Yes, ma'am.
Yes, ma'am. Morning, ma'am.
If I say good morning, then you people also should come forward na to say good morning. Okay, today the LMS portal is down, so I will take the attendance at the end of the session. So now let's start with the where I left yesterday. So I was discussing with you about the significant figures, and I hope this significant figure part you understood nicely. Then we can move on to some of the standard measurement. Now, standard measurement, this we will do, but wait. Okay. Now see here, measurement of standard. Now, whenever we do any kind of measurement, we need to follow some standard. Okay. Only basis of that we can find the true value, and we can. It is helpful for us to compare also. So we can do the comparison very easily. Okay, in case of if we take any standard. So standard are of various, that is one is international standard, primary, secondary, working. Okay, so on these four type of standards we actually work. So this is very important part, that which are the standards we actually take for our calculation easier. So it is important, this part. Another thing is that now it can be only done if you know that what is the particular value or what is the exact value of that particular instrument. Okay, then only we can compare it with the standard. Now let us move on to the next slide. See, international standard is given. That what is international standard? It is defined by the international agreement and are maintained at the International Bureau of Weight and Measuring in France. So the standard has been taken from France, and it is maintained by International Bureau of Weight and Measure in France. So these are accurate and scientifically possible to achieve, and they may be used for comparison with primary standard, but otherwise unavailable for application. So whenever you have a particular standard for your measurement and you need to compare, only at that point of time, this international standard we have to check that what is the international standard for this particular instrument. Okay, so that you can compare it with the primary standard. Clear? Now next is primary standard. Primary standard are something it's maintained at institutions in various countries around the world, such as National Bureau of Standard in Washington. Okay, so this is a very worldwide standard which is maintained, and definitely it is accurate as it is scientifically possible to achieve. Now they are also constructed for the greatest possible accuracy, and their main function is to checking the accuracy of secondary standard. So this is also important. That is, international standard is compared with the primary standard, and primary standard is again compared with the secondary standard. So this is the way how it proceeds. Okay, but both are used. Everything is used to measure the accuracy. Okay. Next, we will move on to secondary standard. So secondary standard are periodically what? periodically checked at institutions to maintain the primary standard, and they are mainly employed in industries. Okay, as you can see here, it's written here, it is mainly employed in industry as a reference for calibration, high accuracy equipment and component, and to verify the account of working standards. So it is also important that see, these standards are used in various instruments. Okay, wherever you need high accuracy, high precision, you go for this kind of standards. Okay, as for calibration of high accuracy and high to get the more accurate result. Okay, then you see next point, working standard, how they actually work. The working standard are principal tools of a measurement laboratory. So if you go to any measurement lab or any laboratory, you will find that every time what we do, we try to calibrate the laboratory instrument. Okay, why we do the calibration? All the lab technicians who are present in the lab, they always check the lab. Okay, they do the calibration of the instrument every time. Why? So that we, when go to perform the experiment, we get the accurate result, and definitely we get a good performance of that particular instrument. Now in our labs, in college laboratories, institute laboratories, it may happen that sometimes we can get errors in the result. But in big industries, what happen if any error comes? Okay, everything is get distorted. So they can't actually, they can't actually bear any kind of error. So every time in big industries, what happen? All the instruments, they are calibrated every second, every time for good performance and for good accuracy. Okay. So that for that reason, requirement of standard is there. Now comes the other summary that which standard is more accurate and why. So you see here, secondary standards are more accurate than working standard. It written here clearly. So it may be asked in any of your question that which standard, I mean, secondary standard is more accurate than which standard, working standard, and it is used throughout the industry for checking the high accuracy of the equipment. Okay, then comes primary standards are more accurate than secondary. This is very, I told you also, and they are maintained to highest possible accuracy by national institutions for calibrating secondary standards. So this thing is very important. Secondary standard more accurate than working standard, and primary standard is more accurate than the secondary standard. And third point is international standard are maintained by international agreement and may be used for checking primary standards. Okay, so where international standard can be used, it is also important to remember. So very objective type of questions can come from this portion from the summary. Next that we will move on to some of the errors. Okay, so I will explain that error through the whiteboard. Let me share with you first. Okay, this whiteboard is visible to everyone. I hope it is visible. Now, you see here, first of all, if we try to find out the limiting errors in or the limiting error or guarantee errors in this kind of quantities that we are measuring. Okay, first of all, let us discuss with you about the actual or you can say limiting errors. Now, what is limiting errors? The first word I am telling you, limiting errors. Not so much proper I can write, so just bear with me. The word is limiting errors. Okay, the word is limiting errors. Now, this is a very important term. This limiting errors can also be called as guarantee errors. Okay, so actually what happened, many instruments have some deviations. Means the manufacturer make the instruments for a specified value, but there remains some deviation from the nominal value, means from the original value. So the limit of these deviations from a specified value are termed as limiting error or guarantee errors. Okay. So these two terms are important, and magnitude of the quantity which is having a nominal value, I'm taking that as NV. So nominal value of any quantity can be termed as AS. Okay. Nominal value of any quantity can be termed as AS. If you have your copy, please write it down. And maximum error or the limiting error, this term, limiting error for that can be plus minus del A. So plus minus del A, it will be just like this. That means changes in the, or you can say it's having a, and this kind of error always should have a magnitude of, it should have a magnitude of A small a. Okay. So this kind of limiting error is having a magnitude of A small a, and it should, the limit should lie between, it should be AS, which is the nominal value of any quantity, AS minus del A. Okay. AS minus del A. And the limit is should be like this, 2 AS, okay, AS plus del. So this is the actually range of, you can say, the magnitude of any quantity having a nominal value AS and the maximum error or limiting error plus minus del A, which is having a magnitude of AA, okay, between the limit of this. So this limit is very important. That is the nominal value minus the limiting error to the nominal value plus the limiting error. Okay, so actual value of any quantity considering the limiting error, we can write as A, this is the actual value, okay, AA equal to the nominal value, that is the AS, clear, plus minus the limiting error. So this is the actual quantity, very important, actual quantity of, means actual value of any quantity. Okay. So for example, suppose, if I say that the nominal magnitude of a resistor is 100 ohm, listen to me very carefully. Suppose the nominal magnitude of a resistor is 100 ohm with a limiting error of plus minus 10 ohm. Okay, this is the limiting error if you consider. Then you tell me the magnitude of resistance will be between the limits. What will be the limit? Can you tell me the limit?
90 to 110.
Yes, very good. Very good. The 90 to 110 will be the limit. That means I can write, I'm moving on to the next page. That means I can write that the value should lie between AA, okay, AA greater than equal to 90 ohm, because I have two signs, na, plus minus. And another limit will be AA, then it should be less than equal to 110 ohm. So this kind of picture I can see when I have taken the nominal magnitude as 100 ohm and the limited error as plus minus 10 ohm. Okay. So in other words, I can also say that the manufacturer guarantees the value of resistance of the resistor should lie between 90 ohm to 110 ohm. Okay. So these are all the manufacturing defect, you can say. Next, we will move on to relative limiting error, or you can say fractional limiting error. That is also interesting part. Now, in let me write first. Next is relative, okay, limiting error. Relative limiting error. So I'm not writing full LE, I'm writing for limiting error. So let us come to And this is also called fractional limiting error also. So relative limiting error is defined as a ratio of the error, okay, to the specified nominal magnitude of a quantity. Means, I mean to say that relative limiting error, if I write like this, okay, epsilon r, that is equal to del A, okay, del A divided by, that means ratio of the error, okay, to the specified nominal magnitude, that will be AS. AS. So this is my ratio of relative error. So I can also write this equation as epsilon 0 divided by AS, okay? And then I can also write the epsilon 0 as, I hope you could understand, that will be equal to ERAS. That means epsilon R AS, okay? This is my another equation for the relative limiting error, this one. Very, very important equation. Now, just now I told you from the equation, the previous page equation, this two equation, that is this one, AS plus del A. This is the, which one equation? AA, actual value of quantity. This equation is important, okay? Actual value of quantity. So from this particular equation, if we try to replace the del A with the epsilon or relative limiting error, then what can we write? What can we write if we trying to replace it? Wait, yeah. If we replace the epsilon, I mean del A with this value, then we can write A will be equal to AS, okay? AS plus minus del A. So in place of del A, I am replacing it with this value, epsilon RAS, because this value is again del A. Okay? If you see this this equation, so I can write it. So in place of del A, I will put epsilon R, okay? Epsilon RAS. So if I take common AS, then what value I will get? Tell me. If I take common AS, then what value I will get? 1 plus minus
Yes,
epsilon R.
ER.
Yes, ER. Or I can say ER, epsilon R, whatever you like. So this is my limiting values, okay, which I have got. And after replacing this del A with my relative limiting error, I am getting this kind of value. So percentage limiting error I can write as percentage limiting error. That means percentage of epsilon R, okay, can be written as epsilon R multiplied by 100. So this is my formula which you require while doing problems. Okay. So this is the percentage limiting error. That is percentage epsilon R is equal to epsilon into 100. So I told you that if suppose in a question may be given to you, if we have, just think of it AS, if we have AS as suppose 100, as I told you, AS as 100 ohm, okay, and you have del A as 10 ohm. So tell me the answer, del A as 10 ohm. Okay, these are the two values you got. Now you will tell me the relative limiting error. Tell me the relative limiting error. That is, you will tell me the ER. Tell me the ER. Tell me the value of ER fast.
ER value should be 10 ohm.
Why 10 ohm? ER is del A. Okay. ER is del A
Yes,
upon S, right? So what it will be? Plus minus. I mean, just like that, na? Del A is 10 and AS is 100. Okay. 100. And you have to also put plus minus here. So it will become, from my viewpoint, it is becoming plus minus 0.1. Okay. Plus minus 0.1 if I do the calculation. So if you are now asked to find the percentage limiting error, then what it will be? Percentage limiting error, percentage ER. Now you tell me, percentage ER will be, where are the other students? Only Pooja is telling me. Eh? Ayushi Priya, Josna, what are you doing?
Ma'am, 10.
Yeah, it will be 10%. Okay, because 0.1 that I'm getting the answer multiplied by 100. If I do, then my percentage will be absolutely it is plus minus 10%. Okay.
Ma'am,
Yes, Rajkumar.
every time we should use plus minus.
Yeah, actually what happened, this is a calibration error na. Error can be error का जो limitation होता है, that can be positive, that can be negative. So we don't know, it depends upon the calibration of the instrument. Okay, so जब तक हम instrument में measure नहीं करेंगे correctly, हमें नहीं पता, we don't know what will be the perfect answer. It may be tend toward positive, it may tend toward negative. So that is why we use this plus minus. So it is a safe side. Okay. If the answer come with positive, we will go with the positive. If negative, then negative. So no one can say us that why you have used in positive you have used negative sign or something like that. So error, as we are talking about error, these things are everything about error. Okay, this epsilon r is a relative error. So when you're talking about error, you should always put plus minus. This is for error calculation, we do this. Okay. Now come to the limiting values of resistance. Then what can we write? So let me complete here only.
Excuse me.
Yes. Yes, Rajkumar, tell me.
Ma'am, what is the signifiers of AS and del A? Please repeat.
Okay, repeat. AS. तो पहले ही तो बोल दिया था शुरू में. What is AS? AS is the nominal value of any quantity. Nominal value means you can say original value. Okay. Any quantity's original value is termed as AS. Okay. And del A, this term del A, it is actually the maximum error or the limiting error of any quantity. Okay. So AS is the nominal value and this del A is the maximum error or limiting error of any quantity whose magnitude is AA. This is I'm writing. So the limiting values of resistance I can write in this formula you already know. It is AS. In bracket we can put 1 minus what? 1 minus epsilon r. 1 minus epsilon r. Okay. And so you just put the values of AS here and epsilon r here and you tell me the value, what it will be. 100, what? 100, then plus minus how much? If you put epsilon r here, then what will be the answer?
10.
Yes, 10 ohm.
10.
So kind of problems are very common from this chapter. Okay, from this module measurement and their errors, this kind of problems are very common. Okay, so relative limiting error, as I am telling you, I'm doing the problem, so you also take your copy and solve it. Okay, because I'm not right now, I'm not giving the notes. Later on I'll give, but still, just say Rajkumar, you are asking me, ma'am, what is AS? I am told in the very first beginning what is AS. AS is the original value of any quantity. Del A is the limiting value I'm taking, limiting error I'm taking. Okay, so I'm taking error, it will be plus minus. And whose magnitude is AA? This one. And whose value we can write as A's equation is always this one. If we find out it in terms of relative error, generally A is having a formula of this one. Let me show you. This is the actual basic formula of A. This one. AA is equal to AS plus del A. So what I have done, relative limiting error, I have just replaced the del A with epsilon. Okay, because I need to find out the relationship in between the relative error and this limiting error. Okay, so relative limiting error and the limiting error. So it is important. Now, another thing, let me. Okay, so here I have ended up. Okay, so 100 plus 10 ohm is my limiting values of the resistance. When my question is, in the question, what is provided? Original value of resistance and the error is given. So we need to find out the limiting error, relative limiting error, percentage, and also the values. Now, as I told you that AS is taken as a true quantity. This is a true quantity, means true value of any quantity. So the quantity which has maximum deviation, okay, thus we can write as AA. We can also write this kind of equation for maximum deviation. That is, suppose we can write that this changes or limiting error is equal to, limiting error is equal to AA minus AS. Okay. This kind of equation we can also have in case of maximum deviation from this AA value, because this is the magnitude of the quantity having this error, that is del A. So we can write relative limiting error, that is ER, epsilon R can also be written as, okay, so epsilon R can also be written as what? Generally,
Del A.
yes, del A upon what? Del A upon AS. Okay, this is my formula. But now I am telling that I can replace del A with this value. Okay, so I will put here simply AA minus AS, okay, divided by AS. So I can also have this kind of equation for my relative limiting error. So ER finally we can write like this also. Okay, so you can replace such the limiting error, that is del A, with A minus AS. So we can write this formula. This is the actual value. This is the, this is the nominal value and this AS is the nominal value. So a question I'm giving to you, write down the question. The value of capacitance of a capacitor, write down the question. The value of capacitance of a capacitor is specified as, the value of capacitance of a capacitor is specified as 1 microfarad, 1 mu f, okay, specified as 1 mu f plus minus 5%. This is the value. So I told you what? The value of capacitance of a capacitor is specified as 1 microfarad plus minus 5% by the manufacturer. Okay. Now you find the limits between which the value of capacitance is guaranteed. So you find the limits between, which the value of the capacitance is guaranteed. Tell me the answer fast. The value of capacitance of a capacitor specified 1 microfarad plus minus 5%. So you need to find out the limit, okay, between which the value of capacitance is guaranteed. I will ask one by one the answers. Josna will give me the answer fast. Very easy. Tell me the answer. You just use the formula and you can get. Which formula you will use? This one. AA equals to AS. I'm also telling the formula also to you people. AS 1 plus minus epsilon R. That is the relative limiting error. You know all the values. Okay. So just you know what is AS. AS is the 1 microfarad. AS is this one. And this ER is 5%. So you have to write the relative error here. What you will write? 1 plus minus 0.05, because it's 5% means 5 by 100. So you have to take the decimal one. Okay. So what is AS? AS is 1. And in bracket, you will write 1 plus minus 0.05. 0.05. Then what is the limit coming? What is the limit coming? Tell me the limit. Come on, tell me the limit. What will be the answer? Rajkumar, have you done this? My voice is audible now. Hello? Hello?
Ma'am, is it is from 0.95 into 10 to the power minus 6 to 1.06 into 10 to the power minus 6?
Yes. 0.95 to 1.05 because plus minus I will take now. So if we minus 1 minus 0.5, it will become some 0.95. Okay, 0.95. And if I do the addition, then it will become some 1.05 microfarad. Okay, so this kind of some value will come. So this is the limit up to which the capacitance value of capacitance can be varied or guaranteed. If we vary the capacitance within this value, it won't get damaged. Okay, so this is the thing why we actually require this kind of calculations for particular quantity. Okay, Achha, one thing you remember that this this type of questions are important. Okay, and next day we will do many more questions on this, but still I want you to jo bhi aaj karaya, whenever you sit in your class now, please sit with your pen and copy. Then it will be easier for you to also understand, or for me also. So today I taught you about limiting errors. Okay, and the relative limiting errors, nominal value, actual value. So it's very important, this formula. AA is equal to AS plus del A. Okay. Why 16 students are there? Where are the other people? Every day, out of 30 students, only 16 students come to class. Not interested? Huh? Not 16 even, it's 15. Why should I include myself? I shouldn't, right? Okay. Do you have any query in this topic? Then please tell me. For any query, tell me. Next time we will do many more questions. So if we do problems, things will be more, you will understand it more nicely. So we will do many more problems in next day on the basis of this limiting error. So do you have any question on this particular topic? Tell me. Rajkumar, understood?
Yes, ma'am.
Okay. So this is one single problem. We have many problems on this portions. Then we have to move on to some of the standard deviation and all. And many problems are there on the basis of standard deviation. So that we will do. So please, it's a request from my side. Whenever you sit in the class, sit with a pen and copy. Okay. Because otherwise you won't be able to understand. Sit with a pen and copy, and whatever I'm writing, formulas, problems I'm telling you, you also write in your copy. Then it will be just like type of notes you are making. Okay, it's a humble request to you all. I can only request to people. I just can't force you. Okay, so any query from this portion you can ask me. So this particular yes, tell me.
Whenever we find out the limits, it was the range.
Yes, it is a range. It is a range. Okay. Now, when we will see any question, you will see they are giving you the AS, that is the nominal value. Okay, and they will give you the delay. Okay, that means the error they will give you, that 5%, 10% error this quantity may have. What you will find out? You will find out the actual value, that is AA. Okay, and that AA value means, actual value means the capacitor or resistance, whatever is given in your question, that will vary only from that value. That means that is a safe operating area for that particular quantity. If the quantity operates in that particular limit, suppose in this case, you see the problem I gave you. Wait, let me show you. This is the problem which I gave you, right? In this problem, what I got, the limit is 0.95 to 1.05. So the capacitor whose nominal value is 1 microfarad, okay, and error may come 5%. So if I use the capacitor between this range, that is 0.95 to 1.05, okay, including the error, because we are calculating it including the error. So the capacitor won't create any damage, and the result we will get, that will be within the limit. Within the limit, I mean we will not get that much of faulty result. Okay, गलत result उतना नहीं आएगा अगर हम इस range के बीच capacitor को हमने use किया. So this is the thing why we need to find out the actual value from the given nominal value and the error. So this is the limits between which the value of the capacitance is guaranteed by the manufacturer. Okay, if you go to a shop, manufacturer will tell you that this capacitor, iska value itna hai aur 5% to 10% error it may come. Then you are the person who will find out the limits, okay, between which the value of capacitance is guaranteed by the manufacturer. So this thing actually we require when calibration problem is there in any instrument or in any quantity. So these formulas are very, very important. Okay, A equal to AS plus 1 plus minus epsilon R, or 1 plus minus del A. Okay, because this formula, on base of this formula, only problem will come. Next day we will do more problems on basis of this. Okay, so this is not only for capacitance and resistor. This is applicable for voltmeter. This is applicable for ammeter. Okay, any kind of measuring instrument you can say, we use this formula. Okay, so I hope I could make you understand this portion. Thank you for attending my class. Today QR code is not working, so let me take your attendance and then you people can leave. But 16 people attendance won't do. It won't. Tell your friends. It won't help them. Okay. Every day I note the attendance who actually comes to class. And if any problem is there, then inform your subject teacher that, ma'am, I am having this problem, so I couldn't attend my class. It's okay. But without any information, other 16 students are absent. So this is a bit weird, right? Okay. Thank you for attending my class. I don't.
Thank you.
Yes. So next we will meet in my next class. Okay. Thank you so much.
Thank you, ma'am.